Okay, I got her.
I don't got that off the dome.
You just gotta memorize it. Yeah, just off the dome. Okay, let's keep going here. Hopefully that.
No, you didn't, because you still got the rest of it. Now it's easy.
Hopefully that first video saved somehow. We'll see. It sucks to suck. The angle in radians that is coterminal 30 degrees. We were going to convert 30 degrees to radians. 30 degrees is on the unit circle, so if you're some sort of like genius who has the unit circle memorized and you're the smartest one in the room, congrats, then you know exactly what radian measurement this is. If they give you a radian measurement, though, that's not on the unit circle, you got to follow our little system, right? Where we know that 2 pi equals 360 degrees. Sorry. That's the harder way to do it. 1 pi equals 180 degrees. That's easier. And we make fractions that are equivalent. So I say, okay, I put 30 degrees on top of my 180, and I put x over my pi, because I'm looking for radians, and I currently have 30 degrees. That'll be your setup anytime you need to convert. At that point, all you need to do is get x by itself. So we multiply pi to the other side, and x equals 30 pi over 180, which can definitely be reduced. Right? If you look at these numbers, 30 divided by 180, you put in your calculator 30 divided by 180, you hit math, you hit frac, it'll tell you the lowest terms you can go. Or you could look at both those things and try to figure out what number divides into both of them. They both divide by 30. So it comes out as pi over 6. If you put a 1 in front, that's not wrong, right? You can put a 1 pi if you want. Okay, I'm looking for a coterminal angle to pi over 6. To get coterminal angles, I add or subtract 360. Sorry, add or subtract 2 pi. I'm in radians. So I got pi over 6. I add 2 pi. For the record, 2 pi is the same thing as 12 over 6. So this is 13 pi over 6. That is not one of my solutions. I see negative 13 pi over 6, but not positive 13 pi over 6. So I take that again, and I add another 2 pi, because maybe it's just did 2 spins around. Again, 2 pi is actually 12 over 6. Right? 2 is equivalent to 12 over 6. So that's 25 pi over 6. And lucky for me, that one is one of my answers. It is D. To get negative ones, I would have subtracted 2 pi, and you would have noticed that neither of these ended up being there either. Yes?
Can you explain why 7 pi over 6 doesn't work?
7 pi, if we think about a sketch, which is another way to approach this question, pi over 6 is here. Yeah? 7 pi over 6 is here. Because that would be 6 pi over 6, and then 7 pi over 6. And you could sketch it to help you realize like which one of these works and which one doesn't. All right. Number 4. Determine the reference angle. Yeah, this is perfect. Like, this is one of those questions that's not on the unit circle. Right? People look at it, they want it to be on the unit circle so bad, but it's not. Right? Looking at this picture, it says a point is on a terminal arm in standard position as shown. The standard angle is 16 pi over 9. Over 9 is not on your unit circle. So you're not going to be able to unit circle this. Your job is to determine the reference angle. If I just sketch the reference angle, that's this. Terminal arm to closest x-axis. To do that, I'm going to try to figure out what would complete this circle. What would get me to this x-axis? This was 16 pi over 9. If I wanted to do a full rotation all the way around, that would be 18 pi over 9. The reason I know it's 18 pi over 9 is because 18 divided by 9 would be 2 pi. To get from 16 to 18, I am missing 2 pi over 9. That would give me a full rotation of 18 pi over 9. 18 pi over 9 is a full rotation of 2 pi. Therefore, A is the right answer. Okay, converting degrees and radians. I actually just did this up there. I should move that question maybe, so it's after we do how to convert. You need this skill mostly for arc length questions. So remember we had problems where we would determine how long around an edge something was, like an arc? When we did those arc questions, you had to be in radians. The formula works only in radians. So you probably won't get a question on the diploma that says convert from degrees to radians. Probably not. But what you will get is a question that requires you to be in radians, and they give you the information in degrees. And then you use this skill to help you answer that question. Most likely, an arc length question. Converting, we just did it, so all you're going to do is you're going to remember that pi equals 180, and you're going to make equivalent fractions out of that. So I want radians, I put x on top of radians. I know my degrees is 50. I have equivalent fractions here. I multiply my pi to the other side. I have x equals 50 pi over 180. 50 over 180 can simplify to be 5 over 18. If you put 50 over 180, you're not wrong. It just can reduce it, right? Always try to reduce your fractions. If I want to convert radians to degrees, it's a little bit trickier, but really not that bad. You're still setting up equivalent fractions, starting with pi equals 180. This time I know my radian. It's 5 pi over 7. And I want to know my degrees. Perfect. The beautiful thing about this setup is that these pi's will cancel each other out. So I really have 5 over 7 equals x over 180. Multiply the 180 over. And throw that thing in your calculator, reduce it. Because it's degrees, actually, you would calculate it. I don't know what 180 times 5 divided by 7 is. Anybody got me? Nobody?
128.6.
Thank you. I was trying to do that in my head, and it was getting way too difficult. I was up to 900 divided by 7, but I couldn't figure that part out. And I don't even know if that's right. I'm pretty sure it's 900 divided by 7. Yeah. And then I knew it was going to be over 100. I just didn't know how much over 100. Cool. Number 5. A rotating water sprinkler makes 1 revolution every 15 seconds. The water reaches a distance of 5 meters from the sprinkler. What is the arc length of the sector watered when the sprinkler rotates after 10 seconds? Give your answer as both an exact value and an approximate measure to the nearest hundredth. Okay, so we've got a sprinkler. That's my sprinkler, you can't tell? What if I put it on a stand? That's a good sprinkler. And it's rotating, right? And it's shooting out water. Start your picture wherever you want. So I'm going to say, hey, it's shooting water like this. And it's going in a circle. You've seen those sprinklers, yeah? It's like, You know, like and then you do the dance move. Like, you know. Okay. That's what we got here. We got a sprinkler, and it's going around. It's doing a full rotation in 15 seconds. One rotation. Cool. Other things we know. We know the distance that this is shooting out. It said it's shooting 5 meters, so I know that this is 5. And I think that's all the info it gives me. A rotating water sprinkler makes 1 revolution every 15 seconds. I've written that down. The water reaches a distance of 5 meters. I've sketched that. What is the arc length? So that means you're talking around the outside of the sector watered when the sprinkler rotates after 10 seconds. So we're looking for arc length after 10 seconds. To just sketch it and guess it, it's going to look something probably like this. If it's 15 seconds all the way around, my guess is that that's about roughly 10 seconds. Roughly. And my goal is to find that arc length. That's the distance around the outside. So I'm roughly looking for this. Perfect. Any suggestions? We saw something similar to this in our notes. I can't remember what it was, though. It was something was rotating. Yeah.
Can you do like 360 divided by 15 and 10 divided by, or 10 times?
You're on the right track. You're saying that you can use a comparison here to figure out how much of the circle you've done, right? And she's dead on, right? So I could figure out what a full circle is. I could figure out that arc length. And then I can use a comparison to realize that this is just like 10 out of 15 around. 15 seconds would be all the way around. We did 10 out of 15. And we can use that to kind of compare and get the right ratio of how far around that arc we got. But the start is finding the full arc length. You got to find that full arc first. Arc length is on your formula sheet. So if you look on your formula sheet, I think it's right at the bottom. Oh, maybe I'm wrong. Maybe it's on the top. Yeah, it's on top. Top left. So your arc length formula is right there. It says that your angle equals your arc length over your radius. Cool. The angle has to be in radians. For a full circle, full arc, what was my angle it went around? I heard some whispers. It's 2 pi, right? If it does a full circle, that radian is 2 pi. Full circle. I don't know the distance around that full circle, so it's still A. But I do know the radius of that circle. The radius of that circle is 5. To solve that, I multiply by 5 to the other side. That gives me 10 pi equals A. So that's 1 full rotation is an arc length of 10 pi. I don't do a full rotation. I only do 10 seconds. I do 2/3 of rotation, which is 10 over 15, right? I do 10 out of 15 as a rotation. If I multiply that by my arc length, my full arc length, that will tell me my 10-second arc length. It's like a ratio, right? Like I'm figuring out the ratio of my circle that I've done here. And if I just multiply that by the full distance, that'll tell me how far I got. How far around I am. So that means we're doing 10 out of 15 times 10 pi. And that'll give me my answer, which is my 10-second arc. I'm just going to call it x. You have to answer as an exact value and an approximate measure to the nearest tenth. So as an exact value, that's going to be 20 pi over 3. As a decimal, oh God.
20.9.
It's 20.9?
20.94, I guess.
20.94? Thank you. Yep.
Why is it 20 over 3 if both the 15 and the 20 wrong? Divided by 5.
Because then, maybe I did it wrong. If they both divide by 5, it becomes 2 over 3. 2 times 10 is 20, and then divide by 3 still stays on the bottom.
Oh.
Because I times it by 10 pi. Yeah. We did a couple like that. I can't remember. I'm blanking right now which ones we did. Something where they gave you a full circle rotation, and then you had to figure out a portion of it. Right? And that's what I've done here. I figured out the full arc, and then I'm just doing a percentage of it. Like how much of that did I actually go around? I only did 10 out of 15 of them. Which big word? Approximate?
No, subtens.
Subten. Oh, they are going to say subtens on the next question. Yeah?
What does that mean?
Yeah, I'll show you. Yes.
Is there a unit for something like this?
A unit?
Yeah. Meters or something.
It would be meters, because the radius was in meters. I don't know. I don't think they marked that. But Alex asked a good question. Like, this is technically in meters. I don't think, I've never seen them dock marks for that. But if you want to just be safe, yeah, it's meters. The arc length will be the same measurement as the radius. Cool. Here you go. On a circle with a radius 4.1 centimeters, an arc of 18.3 centimeters, subtends a central angle of the nearest tenth of a degree. That's a bad sentence. On a circle with radius 4.1 centimeters, an arc of 18 centimeters subtends a central angle. Yeah, kind of just funny worded. We'll draw it though. So I have a circle. That's a line. Last I checked. There's a circle. Circle has a radius of 4.1. And an arc of 18.3. So let's just sketch that roughly. Let's say it goes like this. Let's just call that 18.3. And it subtends a central angle. What they're saying is that if you connected those two edges of that arc to the middle, this subtends is going on the outside of this angle. So you're looking for this. You can tell already my sketch is pretty far off, but it's just a sketch. Okay, to tackle this, I'm looking for an angle. Definitely an arc length question. So I go to my formula. I know that my formula is your angle equals R over A? No. A over R. Perfect. I want to solve that angle. So that means my angle equals 18.3 divided by 4.1. You throw that in your calculator. What's that decimal? Maybe 4 point something, right?
4.463. Don't know. Where do you want to go?
That's good. We'll go with that for now. Because the multiple choice, like it'll be okay. We can just round it. Perfect. My angle is 4.463. I look at my answers, not even close. And my answers are all in the 200s. Yeah, that's because this is in radians. And these are in degrees. So you need to convert your answer into a degree. Looking at those answers, they are all very close together. You're going to want to make sure you use all your decimals. That could be a very simple rounding error, doesn't get you the right answer. So use all your decimals in your conversion. My conversion will look like this. Pi equals 180. We make them equivalent fractions. I'm looking for x. I'm looking for my degrees. I know my radian. It's 4.463 ... There's more to it there. I multiply my 180 to the other side. I throw that in my calculator. And hopefully somebody got it. Which answer is it? A, B, C, D?
A, I'm pretty sure.
It's B?
A.
A? Do we get 255.7? You use all the decimals? I heard you say answer E, and I knew that was wrong. I did not hear that well.
I kind of mumbled it, so I get it.
Well, I kind of don't hear well, so I just got a hearing test done, and they're like, yeah, you don't hear well. I'm like, oh, okay, good. You just confirmed what I already knew, and it cost me $100. I was like, is there anything you can do to help? They're like, no. Like, it's not that bad. Okay, cool. So come back when it's worse? Like, yeah. Cool. Hey. Guess I got a circle, hey? How do you feel about arc length? I think I got another one coming up. Oh, maybe not. This one's definitely harder, just because you have to realize that ratio thing, and that's like a bit of a trick. This one's pretty like standard. Typically, they put a story in there though. Right, like they give some sort of story along with it. This is pretty straight up. The radius is this. The arc is this. That's pretty straightforward. A lot of times it's a story of like a windshield wiper that is 10 centimeters long rotates, right? Like something like that. We got code words going through the class. You saw it. But it does, at the end of the day, just kind of come down to, can you do the formula? Can you remember it's in radians? Because that's key. Right? Like if that is a numeric response question, I bet you the most popular answer is 4.46. People leave it in radians, right? So make sure you convert it to what it asks. Question? I can help. Okay, all right. You got a sign, you know, better than me. If you could partner exam it, now we're talking. I'll see what I can set up. Okay, number 7. If -3 and -4 is on a point on a circle, determine the value of sine theta. Okay, let's make this very clear. I am not looking for theta. It did not ask me for an angle. It asked me for sine theta. Sine of theta equals your y value divided by your r value. It is not asking for an angle. It did not say find theta. it wants you to find the ratio sine theta. Your y value divided by your r value. Cool. To do a question like this, we sketch this point. -3, -4 is going to be down here somewhere. We then take that point and we turn it into a triangle. That triangle went down 4, left 3. I know that because that's the coordinates of the point, right? -3, that's my x, that's to the left. -4, that's my y, that's my down. This distance to the origin we call r. To be able to figure out what sine theta is, I need to know what r is. I need to do Pythagorean theorem. -3 squared plus -4 squared equals r squared. That's 25 equals r squared. That's 5 equals r. Sine of theta equals -4 over 5. Full speed. Yeah, Miss.
When do we use the inverse of second?
That would be if we were talking about cosecant, so CSC.
I mean, like sine like -1.
Yeah, that would make sense. That's when you're finding angles. That's when you use the second sign on your calculator. That's if they said, hey, what's theta, then you would have to do that. And you'd figure out the reference angle theta. Yeah, Colin. Good? You guys can partner test it too. Okay. Number 8. Determine the missing y coordinate for the point -1 over 5y if the point is on the unit circle in quadrant 3. Now, you look at, this is like the standard trick here. People read that question, they go straight to the unit circle, and they lose their minds. They're like, -1 over 5 is not on the unit circle. Like, you're a liar. It is on the unit circle. It's just not one of our special points on the unit circle. Right? We only know so many spots on the unit circle that we have memorized. Right? It's the special angle triangles, 30, 60, 45. Right? Like, those are the ones we know. -1 over 5 just isn't one of those points. It doesn't mean it's not on the unit circle. It could still be on the unit circle. The reason they tell you it's on the unit circle is the unit circle has a radius of 1. Just one. Radius is distance from the middle to the outside of that circle. So when you sketch your point in quadrant 3, that point down here has an x value of -1 over 5, an unknown y value, and a radius of 1 because it was on the unit circle. That's why they told you it's on the unit circle. They were giving you a second side of your triangle. They didn't want you to go look at your unit circle. And that'll drive you crazy. From there, some Pythagorean theorem. In this case, we're doing 1 squared minus -1 over 5 squared equals y squared. Make sure you put brackets around your -1/5. Okay, so that will end up being 1 minus 1 over 25 equals y squared. That means if you put in your calculator math bracket, you have 24 over 25 equals y squared. Cool. From there, you square root both sides. You put in your calculator, you get an irrational number. You get a decimal. Yeah, you get a decimal that goes on forever. We don't like that. We like exact values. That's why I'm doing fractions. So that when I square root both sides, I can actually hand calculate it and keep things as an exact value. When you square root both sides, you square root the top and you square root the bottom. The square root of the top, root 24, is irrational, so you can't calculate it. But you can reduce it. Square root of 24 can be divided by 4. Square root of 4 is 2. And I'm left with root 6. The denominator is 5. That's your missing y value, and it is negative because I'm in quadrant 3. In quad 3. I see deer in headlights. Is that from the rationalizing or the simplifying of the radical? It's been a while. You know what? Like Blue Monday's coming, so I understand. We're all stressed. Root 24. If I want to simplify that, I find a perfect square that goes into 24. 4 can go into 24, and I'd be left with 6. Square root of 4 is 2. Right? That's how I turn root 24 into 2 root 6. I know you know how I do that. You might have forgot, but I know you know somewhere deep down. There's some long-term memories there that you can do that. Okie dokie. Number 9. If cotangent equals negative 3 over 4 and cosecant is less than 0, then the value of sine theta is. So again, I'm looking for a ratio. I'm looking for y over r. Okay. When they gave you these things, they gave you lots and lots of information. It just didn't feel like it. Cotangent. Opposite of tangent, right? Like they flip themselves. Cool. I know that tangent is y over x. That means cotangent is x over y. Right? They flip. Perfect. So what they just did was they just gave you an x and a y value. I have an x value of 3, a y value of 4. I actually don't know which one's negative. I know the negative looks like it's on the top, but it might not be. The reason I say it might not be is because we float negatives, right? We just always write them on the top. So I don't know if this is negative 3 or negative 4. One of them is negative, one of them is positive. The way you determine which one is negative and which one is positive is by this second little tidbit of information that cosecant will be less than 0. I know that cosecant is 1 over sine. So they're saying that 1 over sine is less than 0, meaning it's negative. Sine is my y value. That is telling me that my y value is negative. In fact, it's actually telling me, if I think about it a little harder, it's telling me I'm in quadrant 3. Because I know that my x was the opposite. Right? One of these was positive, one of these was negative. This told me y was negative. That means I must be down here. Yeah.
If x is positive, aren't we
Oh, geez Louise. Who am I? Thank you. My apologies. I drew in quadrant 3. That would be both are negative. I want one's positive, one's negative, and the y is negative, so I went down. So if I sketch this, I have this is 3, this is negative 4. Check and see if that makes sense. See if you've just done the sketch properly, right? Cotangent is x over y. If I took x and divided by y, does it make negative 3 over 4. And it does. Right? So this is good. To figure out sine, I need to know y over r. Looking at that triangle, I don't know r. It's 5. You've probably seen that pattern enough by now, like 3, 4, 5. Right? It's a Pythagorean triple, right? It's like 3 whole numbers, 3, 4, 5. If you're not sure, do Pythagorean theorem, and you would get it. That means sine of theta equals negative 4 over 5, which is A. These types of trig questions are all about, like, can you figure out the little pieces of information they gave you? Because they do give you so much information in such a little amount of writing. This told me a lot. This told me a lot. Right? Can I figure out those things? And then use it. If I give you this, you all can do Pythagorean theorem. Like, I know you can do this. It's the pulling the info out. That's the hard part. All right, number 10. Use the unit circle. You know what? It's a perfect time to not do that question. Because I want to start tomorrow with the unit circle. So let's do number 11. Given, point A is at negative 3, 4, and it lies on a terminal arm. Determine theta in standard position, round to the nearest tenth of a unit. This is 0 less than equal to theta less than equal to 2 pi. That's important here. This tells you two things. It tells you that you're only talking about one rotation. And it's telling you that you have to be in radians. You do have to answer in radians because this question is being spoken of in radians. Alright, with all of our trig questions, we're sketching, right? So let's sketch this out. I got point A, it's at negative 3, 4, so it's somewhere up here. I can sketch that little triangle if I want. Don't know if it's going to help or not, but typically it's a good habit to sketch it. Alright, given. Point A lies on a terminal arm. I've sketched that. Determine. This is what I'm looking for. Determine. I'm find. Theta in standard position. To sketch theta in standard position, that means positive x-axis, counterclockwise. That's theta. Theta is not in my triangle. Theta is actually outside of my triangle. We only know how to calculate angles inside triangles. So to solve this question, you're going to have to figure out this, which I'm going to call x. Figure out this angle, because it's in my triangle. I can do that. And then use my knowledge of this whole thing would be 180. If I subtracted away that, it would tell me what theta is. So find x, 180 minus x will give me theta. To find x, I'm going to do SOHCAHTOA. That means this is my opposite, this is my adjacent, this is my hypotenuse. Opposite and adjacent means I'm using tan. Tan is y over x, right? Opposite over adjacent. Means tan of x equals 4 over negative 3. This is when you do that second tan, right? So inverse tan. and they switch spots. Now, when calculating a reference angle, you put that in your calculator, negative 10, sorry, so second 10, 4 over negative 3, you hit enter. Sometimes it gives you really weird answers. So you might get a really big answer that's like over 90 degrees, and you're like, that can't be right. You might get a negative answer, and you're like, oh, that can't be right. Like, I don't want negative 37 degrees or something like that. What I do when I'm doing these calculations, I'm just trying to find the reference angle so I can make these positive values. You don't need to put negative 3 in. I'm just treating this like a regular triangle when I try to do that. So I go second 10, 4 over 3. And I don't actually put negative 3 in my calculator. That will give me my proper angle in there. When you do that, what does it tell you that x equals?
53. Oh, wait.
Yeah, 53.
3.13 and there's a bunch of
You're correct, but that's in angles. We need radians. So make sure you throw your calculator into radian mode and do the same thing. Second tan, 4 over 3. But 0.927?
Repeat, or not repeating, sorry.
Yeah, it just keeps going. Yeah. That's fine. Perfect. That's this angle. Not this angle. To figure out theta, I'm going to do pi, because that would be 180, right? That would be my whole thing from here to here. And I'm going to subtract away x. So I'm going to subtract 0.927. And that will tell me my angle in radians to the nearest tenth, which is what it asked for. 2 point something. What is it? 2.2? 2.2? My angle in center position is 2.2 radians. It did say nearest tenth, right? So I don't need an exact value. Question, or is that just a lot of math in a short amount of time? Yeah, we're going fast now. I want to make sure we get through as much